We should be able to put on the screen.
Yeah. No problem. Now. Okay, yeah, that's thanks. So yes, as Paula said, I'm going to talk to you about laser used in the automotive industry. We'll touch on e-mobility, and you will see that the laser we're talking about today are a bit more old-fashioned compared to what the two speakers just spoke about. But nevertheless, the CO2 lasers have still got use in the automotive industry. So I'll go through a brief history of our company, the manufacturing facility, product range, some of the markets where our lasers are used, and then we'll move into the automotive applications, specifically the electric motors and two other applications to give you a flavor of what our laser can do. So we've been established in 1998. We've got 22 years worth of experience in the laser industry. We have launched some major products to the market, specifically, for example, the multi-scan VS and HE, which were the fastest marking system in the world, and they're still today the fastest marking systems. We've also introduced the first ever 600 watt laser to the market, and for this laser we won a Queen's Award for innovation. We also had a second Queen's Award awarded to us for export growth. And the major milestone, or the most recent milestone for us, has been in 2019 when we rebranded as Luxinar. So who are we, and what do we do? So we are a British company based in Kingston upon Hull in the northeast of England. We design and manufacture CO2 lasers in our factory, purpose-built factory. We're 173 people there, and we've got an additional 16 people worldwide in sales and support, technical support offices around the world, specifically in Southeast Asia, in Europe, and in the US. And we also have a wide network of independent distributors all over the world for distributing our products and supporting the technology. In terms of the product range, we've got two families of products. We've got the sealed CO2 lasers, ranging from 80 watts to 250 watts for the SR series. These are quite unique in the marketplace because they are IP66, and this is quite unusual for lasers. Very often people are offering IP56 or below 60. So this is quite unique. We also have another range of product from 350 to 1 kilowatt. And all these lasers have been designed with industrial applications in mind. So extremely reliable, they deliver repeatable processes, and they are also easy to maintain. I would even say they are more or less maintenance free. They are sealed CO2. There will be some more products coming through in coming months. So, you know, different technology. So we'd be interested to keep an eye on that. The second range is the multi-scan, as I mentioned it. So this is a plug and play system with its own sealed CO2 laser, cooling system, electronic, software, beam delivery system, and the scanner. As I said, they are the fastest marking system available in the world these days. The HE has been designed for the harsh environment, whereas the VS is more for a clean sort of environment. Both are used also in the automotive industry, but in different kind of markets, as we're going to see in the next slide. So these are some of the markets where the lasers are used, but obviously today we're going to focus on the automotive market. So we have a number of applications within the automotive market. Here we've listed 19 of them, but they are far more than that. And these applications are going to range from paint removal, for example, for bonding to components, rubber cutting, rubber drilling, plastic perforation, and as number one is mentioned here, electric motors. And this is what we're going to look into in the coming slides. The two previous speakers have mentioned welding, but in some applications, like in the stators of the stop and start motors, there is a pre-surface treatment needed before welding these copper components, and it's basically removing the insulating material on top of the copper. The air pins, the bus bars, the wires could be made of different shapes. The coating is also made of different compounds like PEEK, PFA, PIPA, and the laser, the CO2 laser, is there to be able to remove this coating in order to later on allow the welding to take place. The conventional method to remove the enamel would be to use mechanical grinding wheels or chemical components. But the problem with these two methods is that the copper surface is going to be damaged, and the second drawback, which is not insignificant, is the removal of a thin layer of copper on the surface of the conductor. And when you know that copper is quite expensive, after a few thousand of these bars being processed, you've lost a fair amount of copper and a fair amount of raw material. Using a CO2 laser allows you to keep the surface clean but untouched, but also to have a far more flexible process where you can change the way you scan the enamel or the electric coating to be removed according to the shape of the material. So far less toolings needed, far less investment, and also no loss of copper material during the process, which is quite key, especially for people who are just making components and don't want to lose any raw material. So in this specific example, we have stripped an area of about 31 square millimeters in just 3 seconds. As I said, this is just an example because we cannot reveal the exact configurations, a bit like what Chris said previously. We've got some NDAs in place with our customers, so these are just given to you as guidelines and to illustrate what can be done. Obviously, the removal rate, the speed at which you can process this material will depend on the power of the laser, the spot size, and different other parameters such as the thickness of the dielectric and the composition of the dielectric. But the main thing is, being a digital process, there is hardly any tool involved and upfront investment. The second application I wanted to talk to you about was processing of plastic parts. And CO2 is again a prime choice for these kind of materials. It is the process speed is very linear versus the power of the laser, and they are used in many applications, such as cutting bumpers, cutting spoilers, removing paint on components, making holes in rubber, or cutting fabrics. In the next slides, I will just show you some examples of components being processed with the CO2 lasers. And as you can see, the cut quality is extremely good. There's not very often need for a secondary operation to finish the component. And as per the previous application, being a digital application, non-contact application, the changeover and investment cost upfront is extremely low compared to more conventional methods. The last point we wanted to touch on is the way of bringing the laser beam to the workpiece. And with the increased use of automation, robotic applications is becoming the predominant way of processing components in the automotive industry. So there are three methods with roughly to bring the beam to the workpiece. One of them is to mount the laser onto the robotic arm and have a complex beam delivery path, which is going to take the beam through a scanner or a cutting head, then to the hairpins to be stripped, or any other plastic components. Here, the laser should be strong enough to sustain the weight of the laser, but our lasers are pretty light, especially the SR series is up to 32 kilos, so that is not a big issue. The lasers need also to be able to withstand G forces, and again, there's no moving parts in a laser, so there's hardly any issues with that sort of constraint. And the compactness or the small footprint is also quite important for this kind of application. So here, the laser and the scanner or the cutting head is moving around the part to process. In the second method of dealing with these components is the fact that the laser is in this case stationary, and you can either present the component to the laser head, and in this case the robotic arm is handling only the jig and the plastic component. So the beam delivery system is fairly simple in this case. The accuracy of the parts being processed is not as high as other methods, but in some applications like pitching on a dashboard, this is good enough. The other method is also to have a stationary laser, which is on the white frame at the back of the video here, and we'll see it a bit better later on. And to have the robotic arm to move the, you can see the laser at the back, to move the cutting head around the component, which is also fixed on this jig. Far easier for the laser to be handled because it's stationary, the components is stationary, but the beam delivery system is extremely complex and could be challenging for some companies. And on the left-hand side, you can see the finished product, which is a big pillar of a car, where the excess material has been trimmed off the main plastic component. The last thing I wanted to touch on is our application lab. This is used mainly as proof of concept. So basically, a customer has an idea of, maybe stripping enamel from a bus bar, not sure exactly how to do it. We would then carry out the test on his behalf and give him some pointers to how to do it. We will not supply complete systems like large scanning area cells or robotic cells. We will only validate the idea, the concept, using the tools we've developed in-house in our lab. And to mimic and to be as close as possible to the final solution the customer may design, we have a robotic arm driving a cutting head. And the top picture, it's more like a large scanning area with a 3D scanner to compensate for height for fairly flat components. We also have a range of measurement equipment to make sure that the specifications the customer has asked us to meet are met. And again, we will recommend few tips and fixture ideas we have to make sure that the proof of concept will then develop into a proper product. So in summary, we are a CO2 expert company which design and manufacture lasers from 80 watt to a kilowatt. Our lasers are used in a vast range of applications, and especially in the automotive industry, the e-mobility sub-market. And we've seen that, prior to welding these components, sometimes they do need to be surface treated with a CO2 laser. And the application lab for proof of concept is always open for quick turnaround of samples and advice to customers. So that was pretty quick. I couldn't go through the whole applications we have for the automotive industry, so we selected only 3 we thought you could be interested in. There is more information on our website, luxinar.com, or you can contact us and myself directly on the email address on the screen just now. Thank you very much, and if you've got any questions, please feel free.
Thank you very much, Yannick. A very interesting talk. Yes, perhaps I can. We can go through a couple of questions and then move to the discussion session that will be a bit more interactive. So there is a question from Jack Gabzil. My understanding is that CO2 laser processing of hairpins can leave a very fine residual amount of organic material on the copper that could impact weld quality. Could you please comment on it?
Yes, it is right that in some cases there is still a thin layer of residual material on the copper, and some customers will then use a YAG laser to clean up or deep clean the surface before welding. It does happen from time to time. Yes, that's right.
Thanks, Yannick. Another question from Tom Schaffer. So you mentioned no moving part with your CO2 laser. Moving parts are often assumed contains CO2 laser. And then this could be seen as a disadvantage when compared to solid state laser. Could you please explain the setup and how the laser works?
Right, so there's no moving part at all in a CO2 laser. You've got the two electrodes exciting a gas, which is then going to generate energy. And the mirrors are fixed. The beam path is also fixed within the laser head. So everything is bolted together and studied. So moving the laser with the robotic arm will not generate any detrimental effect to the function of the laser. We've also done some testing, and we've tested the laser up to 3G accelerations, which is basically the kind of acceleration that the robot will get to when it gets to the safety position. So far, we've never had any issues with vibration or any sort of loosening components within the laser.
Thanks, Yannick. Another question. We have several arriving here from Rick Callot. Thinking of a heat transfer to sensitive material in the welding process, has anyone tried the picosecond or femtosecond laser pulses? I think that's a more open question, yes, to everyone. So.
The customers are, I'm not sure, they are very secretive. I mean, when we work on a specific project, the customers don't really like to show you the full production line. They will only show you what you want, especially in the automotive industry, being an extremely competitive market. It's hard for us to understand the full process, but maybe other people have a different experience and can chip in.
Another question for Yannick from Angelo Giudici. Is the CO2 laser able to remove all the enamel layer from pin surface, so any additional step is required to finalize the process?
Yes, so all depends on the power level and the spot size you're using to remove the enamel. But yes, in some cases, subsequent deep clean with a YAG is necessary before welding. Not always, but sometimes, yes.
Thank you. Thanks, Yannick. There are also some other questions for the previous talk.